All right, so we are going to talk about our last type of statements that we're going to be proving in this week, and that is greatest common factor. So this is also the last assignment that will be due in semester 1. So again, a reminder, get your stuff in, not just my class, but every class. So let's get ourselves ready for notes. Now, greatest common factor, this is also known as the greatest common divisor, and that's how you'll see it, as GCD as a function of x and y. And we'll say that this is equal to a number, and what this means is that n is the greatest common factor / divisor of the numbers x and y, which means that n is the largest number where n divides x and n divides y. So there's going to be a lot of different proofs with this. I'm going to take you right to a more complex example. Sometimes I like to start with a super straightforward one. Sometimes I want to give you an example of a really tricky one, but I don't want the video to go on for 17 hours. So we're going to look at if a and b are natural numbers, then there exists some k and l that are integers for which the greatest common divisor of a and b, there should be a comma in there, is equal to ak plus bl. So this is the idea is that the greatest common divisor is always going to be the sum of some multiples. Now, what we're going to do is we're going to start with just our hypothesis. So say a and b are natural numbers. And now let's think about the set A as being a set where ax plus by, where x and y are in the integers. So basically we're thinking about all the numbers that are written like this, and we're going to see if we can find one that's the common divisor. So one thing that's also really helpful to note is that a is a subset of the integers by closure under addition and multiplication. So we don't have to worry. We're like, okay, anything that we get in, whatever we get out is going to be an integer. So that's nice not to have to worry about it. Now, what I want to say is, and this is one of the ones that I would not have arrived at this method right off the bat. And so I'm going to go through the final proof, but again, I don't expect this to be everyone's first instinct, which is why I want to show you this example here. So let D be equal to the smallest positive element in A. So since we're dealing with a bunch of integers, and it is a set here, we're just going to say D is the smallest positive, right? And that is always going to exist. 1 might be in the set, 2 might be in the set, 3 might be in the set, but there is a smallest positive. There might not necessarily be a smallest period because of the infinity of the integers. So what we're going to do now is I'm going to prove that D is equal to the greatest common divisor of A and B. So I'm going to tell you that this is true. We're going to now prove that that's true. So the first thing that we're going to do is I want to show that D divides A, right? Because we want to show this. So first we want to show that is true. So say D, excuse me. So I'm going to say A is equal to Q D plus R. And what we want is to show that R equals 0, because we want to show that D divides A. Now, what we know about D is that it is an element of this set, right? It's in A. So I'm going to say, and D is equal to AK plus BL for some K and L in the integers, since D is in A. From there, I'm going to use substitution. I'll say, well, then that means A is equal to Q times AK plus BL plus R. Nice substitution. Again, we want to show that R equals 0, so I'm more worried about R than anything else. So I'm going to solve for R and say that that's equal to A minus quotient AK plus QBL. Then the remainder is equal to A times 1 minus QK plus B times QL. Whoop, I forgot to distribute my negative. Oh my goodness. That's all right. We can fix that real easy. So I'm distributing that negative there. So then I'll say, oop, there we go. So what you'll notice that I've done here is now we know that the remainder is equal to A times something plus B times something. So what this tells us is that R is in A. However, because of the definition of a remainder, R must be between 0 and D, because that's how remainders work when we divide. The maximum remainder is D minus 1. And since D is the least positive integer, so R is less than D, but that's the smallest element. Oh, sorry, not smallest element, but smallest positive element of A. So therefore, R must equal 0. So now what we want to do, I'm not going to take the time to do this. So the next thing you want to do is show that D divides B. It's identical, just with the negatives switched around a little bit and the variables switched around a little bit. So our final goal, finally, we will show that not only does D divide A and D divides B, so we know it's a common divisor, we now want to show D is equal to the greatest common divisor of A and B. So what I'm going to say now is I'm going to say that X is equal to the greatest common divisor of A and B. And what we want to do is show that X is equal to D. So since we know that X divides A and X divides B, and this is where a lot of your problems are going to start for greatest common divisor, we'll say, okay, well that's true, which means that A is equal to XM and B is equal to XN for some M and X in the integers. So therefore D, since D is equal to AK, we're going to replace A with XM times K, and B is XN times L. That's just our definition of D. we can factor out an x, and so now we know that x divides d. So what we know here is that d is a multiple of the greatest common factor. So here, d is a multiple of the greatest common factor. And so what we know then is that d is greater than or equal to x, which is the greatest common factor, right? Because the smallest this could be is 1. However, we know it cannot be larger than the greatest common factor because it is a factor. So since it's a factor, it must by definition also be smaller than the greatest common factor. So therefore, d has to be equal to the greatest common factor. Now, I know that this is a complicated problem. That's why I wanted to walk through it. This idea here, this line, is going to be a big start for most of your greatest common divisor problems. I would love to chat if you have any questions about any of the problems from this week or this semester. Just shoot me an email or set up a Zoom appointment. Talk to you later.